Here we have Pythagorean Trigonometric Identities. So going all the way back to the unit circles having a radius of 1 will ensure any triangle I draw within it has a hypotenuse of 1. So this sine ratio of opposite over hypotenuse gets re-represented by the y-coordinate. Cosine ratio of adjacent to hypotenuse could just be represented as the x-coordinate. Hypotenuse of 1. Pythagorean theorem tells us the relationship between the three sides of a triangle should be the legs squared, summed together, should equal the hypotenuse. In this case, that's going to look like sine theta squared plus cosine theta, the same angle, squared, should equal the hypotenuse squared. 1 squared is 1. Now, they don't usually write it with all those parentheses. That's how you would plug it in a calculator, but you'll see it more often written as sine squared theta plus cosine squared theta equals 1. This is the first identity. The other two identities we'll see are derived from this one, and this one's derived from the Pythagorean theorem. If you can see that, legs and hypotenuse, it'll be easier to remember. The first derivation here is, let's divide everybody by sine squared. So I take that same identity and I hit every term with a sine squared. It will produce an equivalent equation, but I can clean these up into different forms. So sine squared over sine squared, that can just be 1. Cosine squared over sine squared is the reciprocal of that tangent ratio, and the reciprocal of tangent would be cotangent squared. And 1 over sine is nothing more than cosecant squared squared. So here is the second identity you'll see in this world. And the third is simply taking this original and dividing everything by cosine squared. So every term is going to get hit by the same thing in the same way. So we know it's going to also produce an equivalency. And we just got to clean this up term by term. Sine over cosine is tangent. Sine squared over cosine squared is tangent squared. Here we have cosine over cosine equals 1. And 1 over cosine squared would be the reciprocal version of secant squared. So here we have all three of the identities they usually give us. Remembering how they're all kind of related to each other will make it easier to remember. All right, here I have our 3 Pythagorean trigonometric identities. We're going to simply see how they're used to solve or simplify expressions they present to us. So tangent squared theta minus secant squared theta. I have one of those identities that involves tangent squared and secant squared, but they're in a different orientation. So I got to think about what I need to do to manipulate this so that the tangent squared is positive, the secant squared is negative, and those are by themselves on one side of the equation. Whatever ends up on the other side of the equation was what I could substitute or replace this or simplify this to. So tangent squared is positive where it's at. I'm going to leave him on the left side of the equation. Secant squared, if I subtract it from both sides, will become negative on the same side where tangent's positive. So that's a good sign. And all I need to do from there to get those expression by itself would be to move the 1 back to this side. So I'm moving the secant to the left and I'm moving the 1 to the right, making them both the opposite. And so this expression of tangent squared minus secant squared would have to be equivalent to negative 1. Another example here. Let's say I have 1 over sine squared minus 1 over tangent squared. So now I'm kind of looking at my 3 options over here and I'm seeing who would most closely be manipulated into that form. No one has sine squared and tangent squared in the same line, in the same relationship. So I'm hitting a dead end there. But I also have some other tricks up my sleeve. I see these are reciprocals. All of these have a reciprocal replacement. 1 over sine has the exact same value as cosecant squared. So those reciprocal functions work with the squareds as well. Tangent squared could be rewritten as his reciprocal, cotangent squared, because the tangent was squared. And now, lo and behold, these two are both coming out of this middle Pythagorean identity I have. So again, a little manipulation. I need the cosecant positive, so I'm going to leave him on the right. I'm going to move the cotangent over there with him so that I'll have to subtract him and he will become negative. That will have the equivalency of the 1 that would be left behind. And so that could be replaced and has the same value as 1 according to this second Pythagorean identity. Another example, say I have sine on the outside of cosecant minus sine. So cosecant is, I don't even want to start consulting this list until I have at least some functions squared, right? Nothing, even if this matched perfectly over here, without those squared functions, there's no relationship going on. So the only thing I could do, I could try to subtract common denominators. I'm going to go ahead and distribute these and see what happens. So sine times cosecant, its reciprocal, will multiply up to 1, right? 3 times a third, 4 times a fourth. Something times its reciprocal is always 1. Sine times negative sine is negative sine squared. Now I can consult this list now that I have a function squared, and I see the sine squared is negative, so I want to move the sine squared to the same side as the 1, and that'll leave cosine squared in its positive form as my final answer. Last example. Let's say I have sine theta, not squared, minus 1, sine theta plus 1. So this is looking real nice and pretty for this first Pythagorean identity, except that nothing's squared yet. It's tempting, but I can't go over there yet. I got to think of something else, some other way to get the ball rolling here. Binomial times a binomial, I'm going to FOIL this thing. And foiling is going to get me a sine squared, so that sounds like a good path to take. Outer gives me a positive sine theta. Inner gives me a negative sine theta. That's going to cancel out nicely. And lastly, I have a negative 1. So sine squared theta minus 1 is looking close to my first identity. That sine needs to stay positive. I'm going to leave him where he is and bring the 1 over there with him to make him negative, which means that cosine squared's got to get out of the way, get to the other side, which will make him negative as I subtract him across. And so that's going to simplify to negative cosine squared theta. All of these should be able to be reduced to a single monomial, okay? One term if you've done it correctly. There's always another step if you still have a binomial in play somewhere. One term.